Welcome to the fifth lesson in session 6 on graphing quadratic equations. The standard form of a quadratic equation is read ax to the second plus bx plus c is equal to 0, where a represents the coefficient of the quadratic term, b represents the coefficient of the linear term, and c represents the constant term. When solving quadratic equations, we set it equal to 0. However, when graphing, it will always be equal to y. Now we're going to take a look at the graph of a basic quadratic equation using a t-table of x and y values. And we begin with the equation y equals x to the second. This is identified as the parent function of all quadratic equations. Selecting values of x right around the origin, we select -2 to start with. If the value of x is equal to -2, then the corresponding value of y is equal to 4. So -2, 4 is a solution to the equation y equals x squared. And as you can see, it's plotted and represented on our graph. Moving down, we go to -1. That produces a corresponding y value of 1. 0 produces a corresponding y value of 0. Next, 1 produces a corresponding y value of 1. This is the point in the graph where it changes direction. As you can see, your y value is decreasing from 4 to 1 to 0, and at this point it's turned around, changed direction, is now increasing from 0 back to 1, and then at +2 it goes to +4. Notice the symmetry in the y value, in the y column. This is important to note as it's true, holds true in every single quadratic equation. To the right, you see the shape of a parabola. It looks like a U. The vertex is the most important coordinate in the whole parabola. It's the point at which the graph changes direction. The axis of symmetry is a vertical line that passes through the vertex. And the minimum of this function is the y value of the vertex. If the graph opened down instead of up, it would have a maximum value instead of a minimum. Whether it's a maximum value or a minimum value, that value is always identified by the y value of the vertex. Now, how do we find the location of the vertex? The x value of the vertex can be found by evaluating the expression the opposite of b over 2 times a. We then build the table of values around the vertex in a t-table, evaluate, and graph. We're going to use symmetry to help us evaluate. For our example, we're going to use the equation y equals -x squared plus 4x minus 3. We have to start by identifying the x value of the vertex. This is done by taking the opposite of b over 2 times a. So the opposite of b is -4 divided by 2 times the value of a, which is -1. So it's -4 over 2 times -1, which simplifies to 2. So remember, 2 represents the x value of the vertex, and I'm going to place that in the middle of my table on the x column. From there, I fill in the x values by selecting coordinates that surround the vertex. So the values that surround 2 are 1 and 3, and the values around that are 0 and 4. So these are the x values that I'm going to use for my table, and then I'm going to find their corresponding y values. When I plug in 0, 0 to the second power is 0, plus 4 times 0 is 0, minus 3. So the corresponding y value is 0. Now notice, from my vertex, 2 steps away from my vertex in one direction gives me an output of -3. So I know that 2 steps in the opposite direction of my vertex will also give me -3. You can go ahead and prove that by evaluating the equation at x equals 4 to show that you'll get an output of -3. Next, we're going to evaluate 1. So plugging 1 into my equation gives me an output of 0. So since parabolas have symmetry, if I go 1 step in this direction away from my vertex and get an output of 0, I know if I take 1 step in the other direction, I'm going to get an output of 0. So I know I'm going to get 0 at x equals 3. Lastly, we have to evaluate the vertex. When I substitute 2 into my equation, I get a coordinate of 1. Now you can see over on the right those corresponding coordinates: 0, -3, 1, 0, 2, 1, 3, 0, and 4, -3 create my parabola. Now notice this parabola opens down instead of up like the parent function. This is due to the value of a being negative. The vertex for this parabola is the coordinate 2, 1. My axis of symmetry is a vertical line that passes through the vertex, so that's the line x equals 2. And the y value of the vertex in this case is going to be my maximum value. So this vertex has a maximum value of 1. That wraps up our lesson on graphing quadratic equations. To earn credit for completing this lesson, you need to successfully complete the quiz. Please email us if you have any questions. Good luck.